Example 2, we actually could, and I don't know, perhaps should, use the product rule and the sum rule, not the product rule, the power rule and the sum rule. But I'm going to see if we can use the product rule and see how that works for us. So it's going to be f of x equals 3x to the fourth plus 4x times x to the 1/2. Honestly, if you distribute that x to the 1/2 across the parentheses, you will be done within a minute. It's going to take me maybe 5 minutes to finish this using the product rule. But let's see how it works out. F prime of x equals the first times the derivative of the second plus the second times the derivative of the first. So we delivered about to find those two derivatives. F prime of x equals 3x to the fourth plus 4x times, oh, how do we take the derivative of x to the 1/2? 1/2 x to the negative 1/2. And we may need to deal with that negative exponent a little bit, but we'll wait on that. Plus x to the 1/2 times, just a polynomial here, 12x cubed plus 4. If we could just leave the final answer like that, then that would be nice enough. But there's simplifying to do. There'll be combining of like terms to do. In fact, I'm thinking it would be appropriate to factor out a common factor. Let me do one thing to the left. I see a common factor of x there and there. And I think I would like to factor out that x before we do anything else. So f prime of x equals,
We factor out 4 out of the last.
we could factor out a 4 there. Yeah. Now what do I do with the 1/2? Did I factor out the 1/2?
Doesn't that just make it negative 1/2? Doesn't that just mean it's x squared?
Well, the square root of x, or 1 over the square root of x.
There, yeah.
Just want to make this as clean and neat as possible.
So it'd be 1 over the square root of 1/2 x.
Here's what I want to do. I want to say an x right there, 3x cubed plus 4, and the 1/2 x to the negative 1/2. I'm not sure if I want to factor out the 4. I know there's a common factor of 4 there, but since 4 is not a factor of this other expression, I'm thinking what's going to happen after this. Maybe hold off on the 4. X to the 1/2. I may change my mind in a minute. I want to factor f prime of x. See if this makes any sense at all. 1/2 x to the 1/2 times 3x cubed plus 4.
Negative 1/2. The 1/2.
No, you added the x.
X to the negative 1/2.
So you added the x,
Or
right?
multiply?
Yeah.
See, what happened is that this x and this x to the negative 1/2, x to the 1 and x to the negative 1/2 got multiplied together. And I added the exponents to get positive 1/2. And I took the 1/2 out just because I didn't want the 1/2 inside the parentheses. It gets weirder, just wait. Plus 1/2 x to the 1/2, 24x cubed plus 8. Multiply by 1/2 on the outside and multiply by 2 on the inside.
If you multiply the whole thing by 1/2, then the big 12x to 12x.
Only on that side of the equation.
Yeah.
See, basically it's this 1/2 times 2 times 12x cubed plus 4, where the 1/2 is red and the 2 is red. Why the 1/2? Well, I've got this 1/2 over here. I've got that 1/2. And I just want a matching 1/2. If they would match, I could factor a 1/2 out of both of them. That's what I want to do. So there's not a 1/2, so I put one there. And I can't just go putting a 1/2 just because I feel like it. I have to account for that, I have to compensate for that by putting a 2. So effectively, I multiply by 1/2 and then I multiply by 2 over there. And that's like multiplying by 2 halves, which is like multiplying by 1, which is like doing nothing at all. I do it because I need to. All right. So with that extra step thrown in, see if it makes sense to say f prime of x equals 1/2 x to the 1/2. I'm copying and pasting here. 3x cubed plus 4 plus 1/2 x to the 1/2, 24x cubed plus 8. 1/2 comes outside, 2 gets distributed across the parentheses. So f prime of x is equal to 1/2 x to the 1/2 times 3x cubed plus 4 plus 24x cubed plus 8. And we can add them. 27x cubed plus 12. And then factor 3 out of that. Can I catch it all? Maybe. So f prime of x equals 1/2 x to the 1/2 times 27x cubed plus 12. Should I factor out the 3? I mean, I factored out everything else. F prime of x equals 3 over 2, x to the 1/2 times 9x cubed plus 4. How would this have gone had we just used the power rule? I'm thinking it wouldn't have taken as long. F of x equals 3x to the 4th plus 4x times x to the 1/2. F of x equals 3x to the 4.5. That would be 9 halves. Plus 4x to the 1.5. That's 3 halves. So f prime of x, 9 halves times 3 is 27 halves. Subtract 1 from the 9 halves and you get 7 halves. Plus, what's 4 times 3 halves? 6. 6x to the 1/2. I suppose you could call that done because that looks nice enough. Or you could factor out you could factor out 3 halves x to the 1/2. And I think you have 9x cubed right there. plus 4. Woo. Wow. Clearly my objective here is not to sell you on the efficiency of the product rule. Because the product rule itself would have taken way longer than absolutely necessary. In some cases, you just have to look at it and say, you know, a faster way to go would be not to use the product rule, or when we get to the quotient rule, not to use the quotient rule.